Okay, this video we will talk about something called rationalizing the denominator. Okay, I'm assuming that you know how to rationalize the denominator for square root problem. If you don't, then go back and review. Otherwise, this video you'll get lost in this video since we're dealing with, as you can see, the fourth root problem, cube root, and so forth. All right. Okay, let's do a quick recap. Rationalizing the denominator has two meanings. Actually, the two are pretty much the same. This means to remove radical, or radical, sometimes you could have two radicals, from the denominator. Meaning you gotta have a fraction, otherwise you don't have a denominator. Okay, as you can see, number one, clearly there's that fourth root in the denominator. Or second definition is to remove fraction from radicand. Remember, radicand is anything inside the radicals. Like number three, the radicand is that fraction. So we gotta remove that. Okay. And there is a third problem. Third problem is this. Okay, and we do have radical, the square root of 5, in the denominator. All right. Okay, so that's the definition of what rationalizing the denominator is. Okay, let me just erase this because I need space to work here. Okay, let's begin. Number one, what I need to do is I need to make the denominator radicand, the 36xy squared, into perfect fourth power, so that the fourth power and the fourth root here will cancel each other out. Okay? All right. What I'm going to do is I'm going to slightly rewrite this problem so that it looks like, well, 36 I know is 6 squared. Okay? That's the only thing I did. Okay, the reason why I did that is now I'm going to multiply top and bottom. They both have to be the fourth root, since here this problem is dealing with fourth root. And what you put at the top and the bottom in that blue must be identical. So that new thing right here that I wrote has a value of 1. Okay? Meaning I'm not changing the problem. All right. Okay. And like I said, what I want to do is I want to make my new denominator radicand into perfect fourth power. I already have 6 squared, so if I have one more 6 squared, that'll make 6 to the fourth. And that's what I want. 6 to the fourth and the fourth root should cancel each other out, and I should just get 6. All right. Now x only to the first power, so I need x cubed. Again, whatever I write at the bottom must be same at the top. Okay. And y, I have y squared, so I need, just like 6, y squared. Okay, so what do I have here then? What I have is, on the numerator, well, instead of 6 squared, let me just write 36. 36 x cubed y squared. And the denominator is, well, 6 to the fourth power, x to the fourth power, y to the fourth power. Okay? And remember, the fourth power and the fourth root cancel each other out, so my final result is this. Fourth root, the numerator is going to remain as this, and the denominator would just be 6xy. That's it. And I have removed the radical from the denominator. This was my original problem, and that's what happened. Okay. Now sometimes this kind of problem is called simplifying, and I don't like that name because, well, if you compare my original problem, which was this, to my answer, does my answer look simplified? Definitely not. It looks more ugly, got more stuff in it. Okay, so I don't like to call this simplifying. Okay, call this rationalizing the denominator. All right. Okay, and oh yeah, before I move on to number 2, I know you see 36 in the radical, and you may say, doesn't that become 6? No, because here we are not dealing with square root, we are dealing with fourth root. Okay, fourth root of 36 is just fourth root of 36. There's nothing you can do. Okay, so again, if it was square root of 36, that would have become 6. But fourth root of 36, that's it. There's nothing more you can do with that. All right. Okay, then let's move on to number 3. Number 3, like I said before, I do have a fraction inside the radical. So what I'm going to do is I'm going to extend my radical a little bit longer, and I'm going to multiply something top and bottom. And like the previous problem, whatever I do at the bottom must be same at the top, so that the new fraction that I'm writing has a value of 1. Okay, and like before, I want to make my denominator perfect cube, because here now we're dealing with cube root. And I know you see that y has a y to the 4th, meaning this can be simplified, true, but I'm not going to quite do that yet. Okay. All right, so let's look at 32, and how am I going to make that into a perfect cube? Well, I need to look at so-called the multiples of 32. 32 is not perfect cube. Let's take 32 times 2, which is 64. 64 is perfect cube. 64 is 4 cubed. That's what I want. So what I'm going to do is multiply top and bottom by 2. Why 2? Because 2 times 32 will give me 64. All right. And the x, I have x squared, so I need one more x. That'll make my denominator x cubed. Okay, y. Now earlier I said y to the 4th inside the cube root can be simplified, true, but I don't need to simplify here. What I'm going to do is y, oops, what color am I? Hang on. Y to the 4th times y squared will give me y to the 6th. And y to the 6th is perfect cube. That's y squared cube. That's what I want. So what I'm going to do is I'm going to multiply top and bottom y by y squared. Again, remember what I wrote here, this has a value of 1. That means that's important. That means I have not changed my problem. If that is not 1, that means you changed the whole problem, and that's definitely wrong. Okay, so by doing this, what I have then is on the top 6, because I have 3 times 2, 6xy squared. In the denominator I have 64 x cubed y to the 6th. And that's what I want, because everything in the denominator is perfect cube. Okay, then by one of the properties of radical, I know I can split this in 2, or write this as a fraction of 2 separate radicals. Okay, the denominator, instead of 64x cubed y to the 6th, I'm going to write this as 4xy squared quantity cubed. All right, and that's what I want, because now cube root and the cube will cancel each other out, and this is what I have. Okay, and that's it. That's my final answer. All right. Okay, let's do number 3. Now, number 3 is different in that in the denominator we have 2 terms, the 2 plus square root of 5. So some of you may be thinking, well, can I just do square root of 5 over square root of 5? No, that's not going to work, because if you distribute the square root of 5 to the denominator, you still have 2 times square root of 5 plus 5. Well, you have not cleared your radical. So we need a totally different strategy here. Okay, and the strategy here is I need to multiply top and bottom by what is called conjugate. Okay, conjugate means nothing more than these two have opposite signs. So these two are called the conjugate, or conjugate of each other. Okay, and pretty soon you will see another conjugate. Okay, that's in different topic. And to distinguish between the two, we're going to call this radical conjugate because it deals with the radicals. Okay, but for now I'm just going to call this conjugate. All right. Okay, then let's see what happens if I multiply this out. Okay, for the numerator I basically have 2 minus square root of 5 quantity squared. And the denominator, if you look at this carefully, well, I don't need to, it's like a FOIL. This is in the form of a plus b times a minus b. Hope you remember, that gives you a squared minus b squared. And that's nice. Why is it nice? Because the b squared will make the square root of 5 squared, which is 5, and that will remove the radical. Remember, that's all I want. I want to remove the radical in the denominator. Okay, so then that is going to be 2 squared minus square root of 5 squared. Okay, then let me write this out. In the numerator, I'm going to use the a minus b quantity squared. So that's a, oops, not a, 2. It's going to be 2 squared minus 2 times square root of 5 plus square root of 5 squared. Okay, I know I could have written that as 5, but I want to show you every single step. And in the denominator, 2 squared is 4 minus square root of 5 squared is 5. All right. Okay, let's clean this up. What I have is 4, because 2 squared is 4, minus 4 square root of 5 plus 5. And the denominator, 4 minus 5 is just minus 1. Okay, and let me just write this as 9 minus 4 square root of 5 minus 1. Of course, having minus 1 in the denominator is nothing more than multiplying the whole thing by negative 1. So my final answer is negative 9 plus 4 square root of 5. All right, that's it for this video of rationalizing the denominator.